One of the things that we realized early on, it would be really helpful if the twins could pipette their blood specimens.
And so, if there's a need arising on the space station where we need to do a PCR or we need to extract DNA from either a crew member who's suffering an illness that we need to try to identify.
And we had to go through elaborate procedures. It was sent down by rocket ship. So they would draw the blood, it was put on the Soyuz spacecraft, sent to Kazakhstan, and then flown by jet to NASA in Houston, where we could then do the next steps. But it would be better, we think, if they could have done a simple pipetting step.
The International Space Station is such a resource for us to have, and it really would be great if we could perform the kind of molecular biology experiments that we perform here on Earth on the space station.
NASA gave me the opportunity, as well as my postdoc, Lindsay Rosardi, to go on the zero-gravity airplane so we could actually work out those protocols.
Basically, you're traveling in an airplane doing these parabolas over and over again. The experiments that we performed were very successful. We were able to move milliliter amounts of liquids using micropipettes to demonstrate that molecular biology experiments can be done in a microgravity environment.
We actually tested out a variety of different pipetting mechanisms, and we found a very simple, ordinary laboratory pipetter worked really well. In fact, the surface tension keeps things extremely precisely controlled. It's just as easy, maybe even easier, to do pipetting in space as it is on the ground. Kate Rubens, who collaborated with us on this, extended those observations, and she did all sorts of pipetting and DNA handling during her 6 months in space, and showed even more clearly that this is actually very easy to do, and it really should be part of the toolkit that astronauts have.
And that's going to open many doors for future experiments on the space station.